In the July 15, 1969 printing of the West Australian, one comes across an article entitled "Hazards for Men in the Moon Landing." Some had warned that a spacecraft landing on the Moon might carry an opposite electric charge to that of the Moon itself, which would cause loose lunar material to leap up and completely cover the spacecraft. This did not happen to any of the surveyors, and the lunar dust did not stick to their surfaces, with a few noticeable exceptions. In one of these, a many-coloured disc 3 feet above the spacecraft's feet became covered with lunar material when the spacecraft, on command from Earth, set off its rockets and hopped 8 feet across the lunar surface. However, no dust could be seen through the television eye of the craft sticking to the lunar module surfaces far closer to the ground. Apparently, a clod of lunar material thrown up by the blast splattered against the disc like dirty wet snow. It clung there despite the jolt as the spacecraft dropped back to the Moon. It was chiefly this episode that has led one member of a surveyor analysis panel, Dr. Thomas Gold of Cornell University, to suggest that this dust may become a problem on the Apollo landings. For example, he believes that when dust clods are thrown up by the rockets that lowers the two-man module on the Moon, it could coat the windows, preventing the astronauts from seeing whether the landing spot after subjection of rocket blast is level and free of obstacles. What does our friend from Utah have to say about this? On September 29th, 2005, Jay Windley told me this about why there is no dust congealed on the lander.
The exhaust velocity is about 2,500 meters per second, and the entrained particles are moving at approximately that speed. Since there is some question whether the LM touched down before the engine was stopped or vice versa, we have to consider two cases. In the normal profile, wherein the engine was stopped with the footpads still above the surface, the last of the entrained dust would have been many meters away by the time the footpads fell to that point. The LM is only 10 meters in diameter, and at 2,500 meters per second, the last dust to leave the center of the stride would have departed the area of the footpads in milliseconds. In the other case, the footpads entered the flow, which then stopped. Again, there are particles moving at 2,500 meters per second, possessing enormous kinetic energy. The collision of dust particles with struts and footpads are elastic, meaning that the particles will have retained much of their velocity while bouncing off. There is simply little probability in that case that high velocity, high energy dust grains would bounce off the struts in such a way as to alight in the footpads and remain there.
Why would Dr. Gold be concerned about moon dust coating the windows if the plumes would typically move the dust too fast to do so? Especially when he had photographic evidence that the dust would indeed cling onto the lander. If the particles accelerated by the rocket plume travel way too fast to congeal onto the landing pads, how did they manage to congeal onto Surveyor when it fired its rockets? There is no dust on the spacecraft, despite the fact that during descent, Lunar Module pilot Buzz Aldrin stated that they were picking up some dust.
40 feet down, 2.5. Picking up some dust. 30 feet, 2.5 down.
On July 22nd, 1969, the day after the moon landing, the West Australian released a transcript of the ground-to-air communications. There is one glaring difference between the transcript they released and the transcript NASA released later on. In the transcript obtained from the West Australian, Aldrin's "picking up some dust" statement is retained. But in NASA's official transcript, the word "picking" has been replaced with "kicking", implying that Aldrin was referring to the dust kicked up by the rocket engine. When I reminded him of Aldrin's picking up some dust statement, Jay Windley also tried to cover for this missing dust that the lander supposedly picked up.
Picking up does not necessarily mean what you say it means. In American slang, it does not necessarily mean to acquire or retain. It simply means to observe. In the debriefing, Colonel Aldrin describes his observations of the dust in great detail. We do not have to second guess his transmission.
This is absolutely ridiculous. The term picking up is only used in that context when something appears on radar or sonar. And if Aldrin was talking in slang, why did NASA alter the transcript? Interestingly, in the HBO series From the Earth to the Moon, Aldrin's picking up some dust statement is used to refer to the dust that the engine plume begins lifting off the surface.
4 forward, 4 forward. Drifting to the right a little. 20 feet downhill. Picking up some dust.
However, as revealed in the official NASA footage, the engine plume began lifting the dust off the surface long before Aldrin's statement.
100 feet, 3.5 down, 9 forward. 5%. How many bites? Okay, 75 feet. Car's looking good, down a half. 6 forward. 60 seconds. Lights on. 6. Down 2.5. Forward. Forward. That's 40 feet, down 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward.
Windley goes on to say,
When he made that comment, the LM was still 30 meters above the lunar surface. The dust being entrained by the descent engine exhaust was moving away laterally, radiating in a sheet near the ground.
of course, because the moon has no air to move the dust, the only way the lunar soil could have moved is by physical contact with the rocket plume. Now if this plume could reach the dust from 30 meters above the surface, imagine how big a disturbance it would have caused as it spread out across the lunar surface.
To have a powerful rocket engine blast the surface of the moon, blasting away all of the dust, and then find footprints surrounding the lunar lander, that to me would be an impossibility.
On all, and I mean all, the moon landings, all 6 times, there is no crater, there is no dust blown away. This is typical of each landing. So the only conclusion is that this guy was put here by a crane.
We know that, according to Gene Cernan, the descent engine must be shut off 3 meters above the lunar surface in order to prevent the plumes from digging into the ground. But on their websites, the propagandists tell us none of this, and instead, they all claim that the descent engine was never powerful enough to dig a crater in the first place. On March 14th, 2002, Jay Windley said this in response to Bill Casey's statement on radio.
I love the part where he talks about having seen engines in the 10,000 pound thrust range being fired, and how they move giant rocks across canyons. What a crock! Just one Rolls-Royce engine in a Boeing 747 develops over 60,000 pounds, and 4 of them develop 250,000 pounds. A Harrier jump jet thrusts at 37,000 pounds at takeoff, fully loaded, and it doesn't dig right down to bedrock. Casing simply falls into the layman's trap of assuming that rocket engines are always very powerful.
Of course, there is a good reason why the engines of a Boeing 747 don't leave holes in the runway.
They're aimed horizontally. You don't want to stand behind one of those things. If a truck or something goes behind it, blow it right off its wheels. I mean, horizontal is one thing. That was a vertical descent. There was no horizontal descent. This guy has to be a frickin' moron.
Jay Winderley claims to be an aerospace engineer who has worked for Boeing, Airbus, and Grumman. Yet he seems blissfully unaware of another reason why we don't find blast craters on runways. Runways are purposely built to be hardened against high air pressure and also high temperature. Think about it. If you were to design an airstrip that was expected to encounter hundreds of takeoffs and touchdowns per day, would you not design the terrain to cope with such pressure and temperature bombardment? Of course, being pressure hardy and the engines being aimed horizontally doesn't necessarily mean they won't damage the runway.